So very quick review of what we have discussed so far. We have learned how to model a multiple linear regression using the LM function in R. Quick review, guys. We said that we want the dependent variable, our response variable, to be highly correlated to our independent variables. But we don't want the independent variables to be highly correlated with the other independent variables. Otherwise, we might be having what we call multicollinearity. Okay, so what we did initially was to create a simple linear regression model. So let me just quickly run that. Okay, this one. Okay, so I think it's here. Where is that? Our model one. Okay, here. This is our model one. It's a simple linear regression because we have one predictor, education. And we chose education because we looked at the correlation plot and we saw that education had the highest collinearity, had the highest linear relationship with hourly wage. So if I run this, okay, let me just quickly review what we have done so far. So we can also make use of the J tools to have a better looking table. So we learned that the adjusted R squared was only 16%, which means that the model, which means our predictor education, could only account for 16.32% of the variability of your response variable, which is hourly wage. And it's statistically significant. So okay yun, no? However, the intercept is not, but we said that even if the intercept is not significant, we still include that as part of the model. Okay, then we looked at the next thing that we did was to create or include other predictors. We have education, experience, tenure, race, gender, and civil status. Now take note, these variables, race, gender, and civil status, are all categorical. So in R, before you can use them as regressors, you have to convert them as factors, which we did last time. So this is what we did. The race variable in the wage dataset, we converted as factor. So with the gender and the civil status. So what does R do when it uses these character variables, these categorical variables as factors? It dummifies them. And we learned that how many dummy variables are introduced. So the number of dummy variables introduced depends on the number of levels. When we say levels, you have the number of classifications. For example, for gender, there are 2, female and male. Therefore, there will be the number of levels, let's call it L minus 1 dummy variables. So since for gender there are 2 levels, then there will be a dummy variable that will be introduced. Will this account for all the levels? Yes. Yes, because it will only be converted into 1 or 0. So if, and usually the default of R is to use as a benchmark. Okay, when you say benchmark, when you say benchmark, it means that this is a level that will get a value of 0. So alphabetical yung pag-ano ni R, as we learned last time, di ba? So kunyari female at saka si male, since female appears first alphabetically, then it will be the benchmark. Okay, it will be converted into 0. while male gets 1. So when the output is generated, you will notice that you will see that the variable that the factor or the dummy variable, okay, is also printed. Okay, let's just run this. So let's run model 2, this one. So I'm creating another model 2, where I'm regressing hourly wage on all the other independent variables. Data is equal to wage. So if I run this, so we now have here model 2, and then if I get the summary of model 2, okay, then you have this one. So take note, guys, that race is equal to white. What does this mean? Because there are 2 levels here for the race. If you check the data, the 2 levels for race is, okay, let me show that. For race, it's white and non-white. Okay, so since non-white appears alphabetically first, then that will be made as the benchmark, or benchmark, and then so it will get values of 0. So this is converted into a dummy variable. I'm sorry, this one. So all the white becomes 1, and all the non-white becomes 0. That's what we mean by becoming the benchmark variable. Okay, and as I mentioned a while ago, all the levels are accounted for. So this will be replaced by 1. So if we see here 1, then that means that pertains to a white employee. If we see it's a 0, then that means that it pertains to a non-white employee. So when we have, on the other hand, when we have 3 levels, there will be 2 dummy variables. Okay, and in the same manner, guys, the alphabetically, the level that appears first alphabetically will be assigned the 0 value, and the others will be given values of 1. Okay, so that's why we have here race white and gender male. For gender, there are 2 levels, female and male. Female was made as the benchmark. Okay, civil status, married and single. Since married appears first alphabetically, then that was made into a 0. And last time we learned that when we interpret this should be interpreted in light or in reference to your dummy variable, or to your reference variable or benchmark variable. So when we interpreted this, we said that on the average, okay, white employees earned on the average $10 or $11.11 more than their non-white counterparts, ceteris paribus. Okay, although it's not significant. Okay, so this will not be interpreted because it's not significant. But if it's significant, then that's the interpretation. But for here, 1.75 bracket to 1.76, how do we interpret this? It means that on the average, male employees tend to get $1.76 more hourly wage compared to their female counterpart. So it's benchmark, it's reference against your dummy variable. Okay, and it's statistically significant. Okay, for this one, okay, assuming it's significant, on the average, single people tend to receive $0.45 or $0.46 less than their married counterparts, ceteris paribus, although it's not significant. Okay, so here, guys, we performed a test here. You know what that is, guys? The individual t-test. Kaya may t-value tayo dito. No? And you either interpret it using the t-value or the p-value. Okay, I'd like you to consider this question, which we're going to so answer it next meeting, guys. If we're going to use a t-value, ano dapat yung value, minimum value ng t para maging significant siya? Ibig sabihin, ano dapat yung t-value para 0.05 to, yung probability? Kasi sabi natin, how do we interpret if a regressor, if a predictor is significant or not, we can use the t-value or we can use the p-value. So p-value, guys, very simple. When the p is low, the null must go. And we learned what the null hypothesis is. No? For this, there are 1, 2, 3, 4, 5, 6, 7, 8, 8, no? Including the intercept. So 8 separate null hypotheses. HO1, HO2, HO3 hanggang HO8. Unlike this one, guys, na iisa lang yung hypothesis dito, yung analysis of variance, diba? So this is what we call the overall goodness of fit test. So ang hypothesis dito, beta null is equal to beta 1 is equal to beta 2 is equal to beta 8, no? O 7 pala, no? Kasi may 0 tayo. Is equal to 0. Yun ang null hypothesis dito. Only one compared to this individual t-test. All right. So overall, guys, sabi natin, the p-value is 2.2. This is practically 0. So we reject the null hypothesis that all our betas are 0. There is strong statistical reason to believe that at least one of these parameters, at least one of these predictors, one of these betas is not equal to 0. Okay, makikita natin kung ano yon, itong mga significant na predictors. Okay, let me pause for a while, guys. Clear so far? Paki-chat naman please kung clear so far yung discussion natin. You notice, guys, I keep on repeating this kasi this is fundamental to our appreciation of multiple linear regression. Let's not forget yung mga outputs na to. Let's not forget what the story that this tells us. Kasi we will be able to understand more our regression output if we know what's happening, if we know what these are. Okay, thank you so much, guys, for the feedback. All right. Aside from the, remember, guys, last time, dito ko lang ilalagay, no? Yung model 2 natin, guys, this one, they contain lots of things, no? And yung mga elements ng mod 2 can be found by using the names function. Yan. So ito yung mga laman niya, no? Coefficients, residuals. So you can access this. How can you access that? So mod 2, and then remember dollar, and then may automatic. And you can access this. Coefficients, enter. So ito, yung intercept, education, experience, which are all here. Okay, so you can easily access this element. You can access the residuals, which we discussed last time. You can also access the fitted values. These are the predicted values based on our model. Okay, so other things that we can access. Now, so dito, guys, yung overall goodness of fit natin, sabi natin, yung R squared natin dito, adjusted R squared, is 36.2, no? 36.20%. While the adjusted R squared for our first model was only, what's that, around 16 yata, no? Wala yata yung una. Around 16% lang. So mas malaki, guys, yung adjusted R squared, which in terms of the capability of the model to explain your response variable, mas okay tayo, no? Kasi mas malaking percentage ng variability ng dependent variable natin kayang i-explain ni dependent variable. Okay. So here, what we did here was to print out kasi mas maganda yung output na to, guys, in tabular form dun sa JTools sum function, no? As compared to ito, no? Pag kinapin nyo to, guys, hindi masyado maganda sa sa pag kinapin nyo sa Word or sa Ito, this is better. It's also, I think, it follows the APA format except for pwede yata as APA format. Okay. So quickly, guys, we studied the meaning of this. Sabi natin, anong ibig sabihin itong 0.57? Sabi natin, for every 1 year increase in education, saan nanggaling yung year? Well, that's the dimension of education. Ito yung inaano natin. Ito yung ini-interpret natin, yung 0.57. And it's the intercept, it's the parameter for education. Sabi natin, Sa bawat isang increase ng education, hourly wage will increase by 0.57. And it's statistically significant, di ba? Okay? Again, ceteris paribus. Ibig sabihin, kasi ang sabi natin dito, pag nag-increase education ng isang taon, yung ibang variables, wag natin i-increasean. No? Sa education lang i-increase natin. Kaya linalagay natin na ceteris paribus. Kasi pag nag-increase education ng 1 year, tapos experience din nag-increase ng 1 year, hindi na 0.57 effect. Itong dalawa na to. Okay, since this is statistically significant but at 10%. Okay? So questions nun guys sa pag-interpret ng parameters natin. Questions? Paki-chat naman please kung clear yon. So sa exam nyo, kaya nyo nang i-interpret yan ha. Eh, kasi dapat ini-interpret nyo sa exams guys, sa take-home exams, you have to interpret the results. Okay, good. All right. We have model 1, simple linear regression. We have model 2, which is si model 2 natin yung yung multiple linear regression. Now, pwede natin i-compare, no? Sino mas maganda? Excel has a function called ANOVA. Iba yung analysis of variance dito sa multiple regression. Iba naman yung ANOVA pag nagko-compare tayo ng models. Dito, we're going to compare two types of models. We have number 1, the unrestricted model, and number 2, the restricted model. Yung unrestricted model class, ito yung mas maraming predictors. Okay, kaya unrestricted siya relative to the other one which is restricted. So kunyari nagko-compare tayo ng dalawang models guys. Yung isa, 8 yung predictors, yung isa 7. Therefore, in that case, the model that has 8 variables, 8 predictors, is the one that is the unrestricted. The one that has 7 variables, yun ang restricted. Siyempre dapat guys parehong parehong dependent variable yung tinitingnan natin. Hindi pa pwedeng i-compare natin isang model sa isang model na iba naman yung dependent variable na in-explain. Okay, let me see, baka may question. Okay. So, let's quick review lang to guys, no? Nag-ANOVA tayo, ito yung ANOVA natin. All right. Ito guys, we can also use the AIC and the BIC in order to compare models. Sabi natin, the AKIK information criterion and the Bayesian information criterion measures information loss. So the smaller, the better. Mas maliit yung information loss, mas maganda. So ang choice natin dito is dapat kung sino mas maliit na AKIK. In this case, AKIK, AIC is for model 2, the unrestricted is better than model 1. So sabi natin, mas maganda si model 2, yung unrestricted natin based on AKIK or even based also on a Bayesian information criterion. 2790, which is model 1, 2679, which is model 2. Okay. And then this one, guys, yung analysis of variance natin. We're comparing here model 1, model 2, and the null hypothesis is that the restricted model is better. Bakit ganun yung null hypothesis? Kasi gusto natin i-test kung magdagdag pa tayo ng variables ba, ng independent variables, ang predictor variables, mas gaganda yung model natin. Remember, yung unrestricted, yung mas marami. Okay. Dito kasi nabaliktad lang tayo. Usually, ang nangyari yan, sa isang forward stepwise regression, we will keep on adding, magdadagdag tayo. Okay, kunwari, dalawa lang yung variable natin, independent variables. Kung magdagdag tayo ng isa, okay, so ang mangyayari, yung panibagong model na may 3 variables ngayon, yun yung unrestricted. Yung dalawa, yun yung restricted. Okay, so ano ba, guys? It tests, ang null hypothesis dito, kailangan intindihin natin, ha? The restricted model, model 1, is better. Okay, so test natin to. Okay, we can see here model 1, ito yung restricted, si model 2 natin yung unrestricted. Nagkataon lang guys na pareho yung pangalan, no? Pero lagi sa analysis sa Barnes table, ang inuuna talaga niya yung restricted. No? Okay, so what's our p-value? Our p-value is 0.000, etc., 15 zeros and then 2. So which is less than 0.05. In fact, less than 0.001. Kaya nga tatlong arrows. Ano? So conclusion natin, inference natin, we reject the null hypothesis that the restricted model is better. Okay? So sino yung choice natin? Model 1 or model 2? Answer, model 2. Okay? Mas maganda yung gumamit pa tayo ng ibang predictors versus education lang. And it's reinforced by the fact that the AIC and the BIC is lower for model 2 as compared to model 1. Okay? Any questions with that, guys? All right. So no questions. Okay, let's continue. Now, how do we proceed, guys? How do we proceed? Tapos na ba? Hindi pa. Hindi pa tapos yung ano natin, guys. Kasi, merong mga insignificant, di ba? May mga insignificant variables. So what we're going to do is we're going to remove these insignificant variables, but we're not going to remove them at the same time. We're going to do what we call stepwise regression. Yung stepwise regression, nagdadagdag lang tayo or nagbabawas isa-isa, one at a time. Okay? Kasi sometimes, guys, pag nagtatanggal tayo ng sabay-sabay, it's possible na dalawang variables doon are multi-collinear. Okay? Kaya minsan nagkakaroon sila ng problema, nagiging insignificant sila pareho. So when we remove several variables at the same time, baka nagtatanggal tayo ng multi-collinear. Yung pala yung isa, significant pala yun. So we remove one by one, and we call this stepwise regression. Okay, for stepwise. Ano yung stepwise, guys? We will only stop with our model until such time na significant na lahat. So dalawang klaseng stepwise, meron tayong forward at saka backward. Anong difference nila? Yung forward stepwise regression, guys, as the name suggests, we add variables one at a time. Dagdag, pwedeng magbawas. Dagdag, pwedeng magbawas. Dagdag, dagdag, dagdag. So pinaparami natin yung mga variables natin, yung mga predictors natin. Yung isa naman, guys, is what we call backward. Okay, so as the name suggests, i-load mo lahat muna ng variables, then isa-isa natin tatanggalin. Okay, that's what we're going to do here. Okay, we're doing a backward stepwise regression. So, ang tanong, ano yung tatanggalin dito na variable? Kasi 1, 2, 3, 4, including yung experience because it's only significant at 10%. So, ano yung tatanggalin dyan? Ang tatanggalin dyan, guys, is that variable which has the lowest absolute value ng t. Ibig sabihin, disregard, guys, the sign, the negative sign. Hanapin natin yung pinakamaliit na value ng t. No? So in this case, ang titingnan natin si number of dependents, si civil status, okay, si race white, okay, at saka si experience. Okay. Now, case in point, guys, ha. Ito, guys, yung mga factors natin, mga dummy variables natin, sometimes, pag, kunyari, tatlo yung levels. So, magkakaroon tayo ng, kunyari, race, white, brown, at saka non-white. Example lang, ganun. So, race, may white, may non-white, may brown. So, ang mangyayari niyan, guys, si brown na magiging dummy variable. Tama? Class? Tama ba? Mag-annotate niyo ako. So, I'm looking at an example, guys. No? Okay, so, let's say, ang race, si race natin, tatlong level siya. We have 3 levels. You have white, non-white, at saka brown. So, therefore, ilang dummy variables ang i-introduce dito, guys? Dalawa. Kasi the number of levels minus 1. Okay? So, magkakaroon tayo ng dalawang columns, dalawang variables. So, yung places na lahat ng mga white, 1 sa doon. Yung places ng mga non-white siya, 1 siya dun sa another column na yun. Okay, dun sa brown guys, okay, since alphabetically siya yung nauna, siya yung magiging 0. So walang column for brown. But, kunyari ganito, no? Ito yung white natin, ito yung column niya. Ito yung non-white natin, ito yung column niya. Okay? So kunyari yung unang white, so 1 siya dito. Dito 0. Tapos yung second observation, non-white, so 0 to, 1 to. Tapos yung susunod brown, so 0 to, at saka 0 to. So naka-capture guys. Kahit na dalawang kahit na dalawang dummy variables lang ilalagay natin, maka-capture natin yung third, yung benchmark natin, yung reference. Okay, so ang lalabas dito guys, sa coefficients, dalawa yan, no? Kasi meron tayong white at saka non-white. So you have race na white at saka race na non-white. Okay? Am I clear guys? Paki-chat naman please kung clear so far yung pag-explain ko or you want me to repeat what I'm saying here. Paki-chat naman please guys. Okay, good. How about the others? The rest? Okay, thank you. Good. All right. So, lumabas dito guys, race white, race non-white. Tapos, si white, significant. Si non-white, hindi significant. Tanong, tatanggalin ba natin si Gagawin ba natin candidate si non-white? Answer is no. Okay? No. Kasi si white significant, si non-white, doesn't matter si non-white kung hindi significant. Dapat kasama pa rin yun sa kasama pa rin sa model natin. Because one of the levels is significant. Okay? I hope you remember that, guys. Kasi minsan may mga lumalabas na ganun. And that's a common question. Okay, so balik tayo sa natin. Ano yung pinakamaliit na p-value dito? Ang lang naman natin, ang candidates natin, yung mga hindi significant. Tsaka talagang yan ang lalabas, guys, ng pinakamaliit na p-value. So 1, 2, 3, 4. And it turns out, guys, that the lowest na non-significant na p-value is 0.257. So dito, guys, since iisa lang naman yung level niya, race white, we can remove this. No? We can remove this. So ang unang tatanggalin natin si race. Okay, take note, guys, ang variable natin si race. No? Race white is just a dummy variable. Okay, so far clear, guys? So dapat ito, this is what we call the leaving variable. Yung paalis, no? Leave. Leaving. No? Yung umaalis na variable. Okay, so let's continue here. Okay, clear ko muna to. Then, okay, so the next step, guys, is now to come up with a new model. So ano yung bagong model natin? This is now our new model, Model 3. Okay, so sino na to? Hourly wage, education, experience, tenure, gender, civil status, number of dependents. 1, 2, 3, 4, 5, 6 na lang, kanina 7. Sino tinanggal? Si race ang tinanggal. Okay, di ba? Race, kasi isang level lang naman siya, tapos race being the one with the lowest absolute p-value. Okay, so pause again, guys. Clear so far tayo? Paki-chat naman, please. Kung nakakahabol tayo dun sa concept ng stepwise regression. So one at a time, no? Right? So let's see. Good. Thank you. Thank you guys for your responses. Appreciate ko yan. Or, guys, another way is this one. You can also write this. Model 3 is equal to LM, hourly wage, regress. Yung tilde and dot, ibig sabihin lahat ng variables. Okay? And then, ima-minus lang si race. Minus race. There's also another way. I'll just teach that in next time na lang. So maraming ways na para gawin to. No? Okay, this is, ito yung regular way. Sinusulat natin lahat ng mga predictors natin May tinanggal na tayo, di ba? May living variable na tayo. Or, yung lahat ng predictors minus si raise. Okay? So let's run now. Ito na lang i-run ko. Control Enter. And then, sa summary, ito na. Summary, Model 3. There we go. All right. So, what do you notice happened, guys? Tingnan natin dito. Intercept is still significant. Experience is still significant. Education pala, significant. Experience is significant at 10%. Siya ba rin yung kanina? Let me just check. Experience natin. Significant siya at 10%. Okay, siya din yan. Okay, and then, si tenure, si gender, significant. Si civil status, hindi significant. Si number of dependents, hindi significant. Okay? So how do we interpret this, guys? Itong gender male na to? For every, ano pala to? A dummy variable, no? On the average, male employees receive $1.76 more than their female counterparts, ceteris paribus. Okay? Si single, although hindi siya significant, guys, let's assume it's significant, on the average, single employees receive $0.47 less siya kasi negative, than their married counterparts, ceteris paribus. Okay? So I hope you're getting the feel of that, guys. Just make sure to include yung ceteris paribus sa dulo. 0.57, for every 1 year increase in education, there's a corresponding $0.57 increase in hourly wage, ceteris paribus. All right? Okay, so is this the final model? Okay, not yet. But before we go to another model, i-check muna natin kung sino ba mas maganda. Mas maganda ba yung tinanggal natin yung race? Diba? Kasi tinanggal natin yung race dito eh. So let's validate that. First, let's take a look at the adjusted R-squared. In terms of adjusted R-squared, mas mataas tong Model 3 natin. So you notice, guys, na if you keep on increasing your independent variable, laging madadagdagan si multiple R-squared. Guaranteed yun. Kasi every time you include more variables, dagdag ka ng dagdag. Talagang tataas tong multiple R-squared. Kaya nga, guys, merong another measure called adjusted R-squared, which will penalize you for adding more variables na some of them might not be relevant. No? Kaya nga meron tayong pag-compute ng tinatawag natin adjusted R-squared. And when we have multiple linear regression, ang tinitingnan natin, guys, yung adjusted R-squared. Okay? That's what we look at, yung adjusted R-squared. Okay, so we now take a look at this. No? Ito, goodness of fit test is okay siya. P-value is less than 0.05. Sabi natin, we reject the null hypothesis that beta null is equal to beta 1 is equal to hanggang beta 6 na lang kasi nabawasan ng isang predictor. No? 6 na lang yung predictor natin. Alright. So here, tingnan natin, guys, compare natin yung akaike ni Model 2 at ni Model 3. Alright. Si Model 3, guys, mas maliit yung akaike niya. So in terms of akaike, so mas maganda si Model 3. Mas maganda yung restricted model, di ba? Model 3 now, guys, is the restricted model kasi si Model 3, 6 na lang. 6 na lang yung predictors niya. Okay. So let's now use ANOVA. Tingnan natin, guys, kasi ito talaga yung test talaga, yung statistical test using ANOVA. So it's better than yung AIC, okay, then also the adjusted R-squared. Ito talaga, statistical test talaga ito. So take note, guys, the restricted model is Model 3. Kasi siya yung binawasan natin. Siya yung mas konting predictors. Okay, so let's run this. Okay, what happens, guys? Okay, take a look, guys. Si Model 1 natin, here is your restricted, yung mas konti, no? Yung mas konti. Si Model 2 is your unrestricted. So it turns out, guys, that the p-value is 0.7971. So anong conclusion natin dito? Do we reject or fail to reject the null hypothesis? Paki-chat nga, guys, ang answer nyo. Based on the p-value 0.79, do we reject the null hypothesis or we fail to reject the null hypothesis? Could you please, guys, everyone? Waiting for your answer. Okay. Thank you, Samir. How about the rest, guys? Take a look at the null hypothesis. Kasi yun ang, pag alam natin null hypothesis, malalaman natin kung paano sasagutin yung yung question na yun. The rest, guys, walang question, walang answer. Okay, walang sagot yung iba. Okay, Samir, could you, is it okay for you to unmute yourself and explain bakit fail to reject?
Sir, I think if I remember correctly, the null hypothesis is if P is less than 0.5, you have to 0.05, yes sir, 0.05, you will have to reject the null hypothesis. But here P is greater than 0.05, so it fails to reject the null hypothesis.
Okay, correct. No? Thank you, Samir. You're correct. We fail to reject the null hypothesis kasi nga, guys, itong p-value natin, 0.79. I-link natin dito yan. No? So, ano ba yung null hypothesis natin? Si restricted model, yung tinanggalan natin ng race na variable, yung mas konti na lang yung predictor. Yung 6 na lang yung predictors natin. Siya yung model 1 natin dito, dito sa pag-call ng formula ni R. Yung model 2 natin is the one with more variables, which is, in our case, siya yung model 2. No? Okay, so we fail to reject the null hypothesis. Ergo, guys, mas okay si model number 3. Okay, mas okay yung mas konti lang yung predictors. Okay, so once again, guys, we debunk that notion that the more the predictors, hey, mas okay tayo. Hindi. Dapat magtatanggal tayo ng mga insignificant based on the lowest p-value. Okay? All right, so this, guys, I hope it's clear na you just don't stop at doing regression. What you now do is you test, compare the AIC, compare the adjusted R-squared, and then ultimately you compare the ANOVA and try to see if mas maganda nga yung mas lesser na variable as compared to, mas maganda yung mas greater number of predictors as compared to the restricted model. All right, so tingin tayo dito, guys. Based on our t-value, sino yung leading variable natin? Which now will be our leading variable. Okay, I expect everybody, guys, to answer, please, ha? KU, thank you. Sino pa? Yung iba, please, pakisagot naman. Leaving, guys, yung leaving, yung aalis na variable. NumDep, si Samir, sino pa? NumDep, according to Willie. I'm waiting for 3 more responses, guys. How about the rest? Ano na lang pala, 2, kasi 6 lang kayo. Sino pang hindi nag-respond, guys? Okay, hindi nagre-respond lahat. Sana, guys, yung next question natin, I hope everybody responds, no? Kasi ilan lang ito nag-respond. Ayan, thank you. Yung next time, i-ano mo to everyone, kindly share to everyone para makita ng iba yung mga answers natin. Okay, thank you guys, thank you. So the answer guys is, ano yung basis natin? The smallest p-value. Smallest absolute p-value. Okay, so don't mind the sign. Tingnan nyo guys kung sino yung aalis. So si number of dependent. Okay, si number of dependent. Education will say because in fact, it has the highest p-value and it's the most statistically significant among your predictors. So, hindi siya aalis. Ang aalis natin si number of dependents. Alright, so iterate na naman natin model. Ulitin natin. Okay, so we once again do regression. Okay, so ito na, let's call it model 5. So 1, 2, 3, 4, tinanggal na natin si number of dependents. No? Okay, summary natin to. Again, summary. Alright, tinan ulit natin yung result. Uy! What do you notice, guys? Lahat significant na, no? All are significant. Pero yung adjusted R-squared natin, bumaba. Okay? Bumaba. So kasi kanina 36.3 yata, ngayon 36.04. Okay, so that might, tingnan natin guys yung AIC. So let me yeah, it's okay, you. No? Thank you so much, you. Yeah, you're correct. No? So, nalito ka lang doon. Kasi ang tanong ko kung sino yung aalis. Kung sino yung mag-stay, yung pinakamay karapatang mag-stay, siya si education. Kasi siya si highest na p-value, which means lowest yung na p-value. So, siya yung most significant. So, tingnan muna natin guys, si AIC ni model. So, model 4 tayo as compared to AIC model 5. Tignan lang natin, no? So based on AIC, small letters comes. Very sensitive si R sa mga ganyan. Ay, model 4. Wait. Okay. Sorry parang nag-jump ako, no? What's my model? One, two, three, four. Hindi ko man naran to. Oo. Oy, sorry guys, sorry. Mali ako Ang naran ko yung model 5, no? Model 4 pa palang pala tayo. I'm sorry guys, medyo tumalon ako, no? What happened was, tinanggal natin yung number of dependents, no? 1, 2, 3, 4, 5. So, naging 5 na lang to. Okay, naging 5, tapos rinan ko ulit. Ang nangyari dito, may isa pang hindi significant, no? Si experience. Alright? You can see here, guys, that experience is not significant. Okay? So, we will also compare si Model 3 and Model 4. Ito, compare ko si Model 3 and Model 4. Okay, it turns out, guys, na halos pareho sila, no? And in fact, si Model 4, yung better kasi mas mababa siya. No? So, okay tayo in terms of AIC. Ang pinili niya, yung Model 4, which has then lesser number of predictors. But ang acid test talaga natin si ANOVA. Okay, take note guys, si ANOVA, si Model 3, mas maraming mas maraming predictors. Si Model 4, yung mas konti. Pero pag kinol ni R yan, natin to, yung Model 1 niya, yung Model 1 niya guys is, okay. Model 1 niya dito, yung yung unrestricted, no? Will it matter guys? Kalimutan ko to. Model 4, kung balik rin natin. Model 4 versus Model 3. Okay, oo. Alright. So, ang inuuna niyang pinaplot, yung unang nag-a-appear dito, Model 4, na mas konti yung predictors. Okay? And then Model 3, ito. So, ang ginawa niyang Model 1, yung nauna dito. Alright, so what's our conclusion, guys? Our inference, point 18. So, we failed to reject the null hypothesis that, ano null hypothesis natin dito? That the restricted model is better. Okay, so it turns out guys dito, mas maganda ito yung model natin. Yung 1, 2, 3, 4, 5. 5 na lang yung predictors. Mas maganda yung restricted kaysa sa unrestricted because the p-value is less than 0.05. Okay. So, balikan natin yung model natin. Iisa na lang guys yung hindi significant. No? Isa na lang. And that's experience. That's experience. So we will remove this. Tatanggalin natin itong experience na to. So that will be our leaving variable. Okay. So we now have, ito na yung rinan ko kanina, education, tenure, gender, civil status. Wala na si experience. No? Tinanggal na natin. So when we run this, all right. So all now are statistically significant. Okay? All are statistically significant, pero mas mababa yung ano natin, adjusted R-squared. Kanina 36.20 yata, no? Mas mataas yung adjusted R-squared ng model number 4. Let's check itong ANOVA natin. ANOVA, okay? So, naran ka ba? Okay, here. All right. So, ang ano natin guys, ang null hypothesis is that model 2 here is better. You must contain predictors. No? Yung restricted model natin. Okay, and we fail to reject that null hypothesis. Point 11. Mas maganda guys si restricted model vis-a-vis the unrestricted. So, the implication is that the addition of gender, okay, the addition of experience, no, did not improve the model. Kasi tinanggal natin yung experience dito eh. And we were able to statistically show that indeed, mas maganda yung restricted model na ito. No? Now, just for purposes of illustration, no, let me just illustrate. Just for purposes of illustration, mag-LM ulit tayo guys. Okay. So let's copy this. Let's create a model 6. Control C. So na siya. Okay, here. Okay, I'm going to create another model. Model 6 na ito ngayon, no? Model 6. Tapos kung titingnan natin sa ano natin kanina dito, ang pinakamaliit na t-value si civil status single. Okay, although significant siya, pero least significant siya, tapos pinakamaliit siya na t-value. So we're going to remove civil status. Let's see what happens, guys. Kung statistically significant na nga sila, tapos magtanggal pa tayo, no? Tanggalin natin si civil status. Yan. Okay, and then let's call this mod 6. Okay, so, right? So what happened, guys? Okay, bumaba yung adjusted R-squared natin. Statistically significant pa rin lahat. Okay, then let's compare the AIC and then let's compare the ANOVA. Control Alt I, AIC ni model 5. Alam. AIC ni model 6. Compare lang natin. And then dito, mag-ANOVA tayo. ANOVA, model 6 versus model 5. Okay. I repeated the process, guys. Let's see. Si model 6, guys, tinanggal natin si civil status, no? No, si experience pala. Sorry. We remove no. Ano tinanggal natin? what did we remove? Civil status, I think, no? Yeah, civil status. Okay, so although it's significant, no? Significant at 0.05. Okay, so let's compare their AICs. Okay. So dito guys, based on AIC, mas okay si Model 5. No? Yung 4 yung predictors versus ito, 3 na lang. Mas okay din yung niya, yung adjusted R squared. Ito 35.4 yung Model 6, yung Model 5 36 point something. And then ito yung statistical test, no? Let's see ANOVA. All right. So here you have 0.01. So this is less than 0.05, diba? So ang conclusion natin, we reject the null hypothesis that the restricted model, which is Model 6, yung restricted yung binawasan pa natin, is better than Model 5. So mas maganda si Model 5. Okay? Kasi significant na yung civil status dun eh. Tapos tinanggal pa natin. Di sayang naman yung yung variation na kayang i-explain ng variable na yun. Okay? Alright, pause muna ako guys. Pause muna ako. Okay, clear so far? Any questions? Pa-chat naman please kung okay tayo. Alright. Okay, thank you. Thank you. Okay, so ito guys yung yung diagnostic test, babalikan natin yan, no? Okay. Let's first go to an automatic way to do stepwise regression. Kasi what we did guys was to do this manually, no? Minanual natin siya, inisa-isa natin. But you can make use of the OLSRR package to generate the stepwise regression automatically. So hindi na tayo yung gagawa ng ng stepwise regression. CR na yung gagawa para sa atin. Okay. Question, please. I think I gave you the codes for this one, diba? Method 1. Are your codes complete? Nabigay ko ba? Paki-chat naman please kung let me check yung worksheet mo. Yeah, I think I gave it. So meron, di ba guys? May binigay ako sa inyong code. Okay, good. So, let's see guys. Let's now look at this, yung stepwise regression. I said 2 types yan. Forward regression. Si OLSRR, yung package, may dalawang klase din siya, no? Forward regression using p-value and forward regression using AIC yata. Yeah, I think AIC. Okay, so we're going to use OLSRR. This is the package for this stepwise regression. So mag-create tayo ng model. Let's call it model. LM. Ito yung lahat, di ba? Ito yung lahat. Education, experience, tenure, race, gender, civil status, number of dependents. So 1, 2, 3, 4, 5, 6, 7. 7 predictors. Data is equal to age. Or I said another way to write this is LM hourly wage tilde and then that. No? Okay. So run muna natin to. Tatawagin natin siyang model. No? Mod 1 yung kanina. Mod 2 yata. So let's just call it model. Make sure guys na naka-library na yung OLSRR nyo. No? Otherwise, hindi mag-work itong code na to. No? Yung OLS step forward. Alright, so I'm going to run this first one. Okay. And then I'm going to run this. Okay, take a look at this, guys. I'm now creating this object forward fit.p. So this is forward stepwise regression, and then fit, ibig sabihin yung mga fitted values, and then that p Okay, of course, arbitrary to guys, ha? Ang ginamit lang natin to kasi P, P model ang gagamitin natin. Tingnan niyo yung function. OLS, step, forward, underscore P. Ito yung function. Ito yung function na gagamitin natin. Mag-OLS siya using P value. Okay? Kaso forward to guys, no? Forward stepwise regression. Iba kasi yung ginawa natin kanina. That's backward. And then, P-enter. Anong ibig sabihin ng P-enter? Okay, P-enter, ibig sabihin yan, kapag yung, ano niya, yung value ng P niya is less than 0.05, dapat ipapasok natin siya sa model. Okay? So, naran natin na yung model. I'm now going to run forward fit. Now, remember guys, kapag may parentheses, ibig sabihin nun, automatically ipiprint niya yung result. Okay. Alright, tingnan natin guys yung ano. Okay? So, when we did this, open and close parentheses, it will give us a short summary of the results. Ayan, may result siya, no? Take a look at this. Ano ibig sabihin nito? Unang-una, education nilagay. Okay? Tapos may measure dito ng adjusted R-squared. Tapos, ito yung Mallows number. Didiscuss natin to next time na lang. AIC at saka RMSE, which means root mean square of the residuals. How do you compute for this? Diba yung RMSE is just, you get the RMSE root mean square of your error terms. You get the difference between your fitted value and your actual fitted value and your actual value. And then you square that. Okay, squared. And then, so lahat may squared na, no? You get the average, and then you get the square root. So that's the root mean square. Okay, syempre, the lower the root mean square, the better. So, ibig sabihin, measure ng error yan. Alright, tingnan nyo guys kung paano ginawa niya yung forward. Una pinasok niya education. Okay, yung Akaiki 277, kung iisa lang sa education. Second step, dinagdag niya si tenure. Notice from 16%, naging 29% yung almost 30% yung adjusted R-squared natin. AIC went down. But 2777 naging 26 AI 815. Pati si RMSE, bumaba. So okay itong mga to. And then ang pangatlong pinasok niya si gender. Okay, adjusted R-squared is going up. Okay. R-squared pala to, ito yung adjusted R-squared. And then Akaiki also went down. RMSE also went down. And finally, ito na dinagdag niya, civil status. Okay, tumaas si adjusted R-squared. Okay. And then si Akaiki, nangyari, bumaba. RMSE, bumaba. So this is the summary of your forward stepwise regression. Now, kung gusto natin i-print lahat, okay, ito yung natin, forward fit.p. Let's run this. Okay, so here we have the sandali, bakit hindi niya print lahat? Ay, sorry. Hindi pa, no? Okay, so ganun din pala to, no? I'm sorry guys. Pareho lang itong nasa sa kanina. Kasi putting this in parentheses, yung code na to, will print it, or typing the name here, forwardfit.p, will also print it. Pareho lang. Apologies guys. Ang hinahanap ko yung mas complete. Okay, so ito na pala yung mas complete. Take a look at this. Let's call it forwardfit1.p. Ganun din, ito din yung function. OLS step forward p. Same then, using the model, p entered in is 0.05. Then, andito guys. This will now give us the details of what was happening. Okay, so when we run this, take note, naka-parenthesis, ibig sabihin automatically, ipiprint na yung output nito. Alright, as you can see guys, di ba, ang daming laman. Okay, ang haba. Kasi sabi natin, P details is equal to 3. All right, let's quickly take a look at what this very long output give us. Okay, so ito yung mga candidate variables natin, di ba? Tapos isa-isa siya. Step 1, i-add daw sa education. Paano niya kaya kinuha yun? Malamang niyan, hinanap niya yung variables na mataas yung correlation with your dependent variable. So nakita din natin yan, di ba? Nung pinat natin correlation. So you have plus education. And then when you use education, ito yung parameters ng regression natin. Adjusted R-squared, di ba? 16.3 lang yun. Okay? Tapos ito din yung measurements ng mga errors. Root mean square error, mean square error, mean absolute error. Okay, baka may question?
Sir.
Yes, on. Mariel, ano nangyari? Sige, gawin kitang can you show your screen?
Sir, okay na po yung akin. Si
Okay.
Stephanie.
Steph, ikaw ba? Steph?
Sir, I have a question. What's the difference of adding the details equals true?
Okay. Ang difference, guys, di ba kanina nung walang details is equal to true, ito lang yung lumabas, no? Di ba? Short summary lang siya. Pag details is equal to true, hindi pa kasi natin, tingnan nyo guys. Ayan, ang haba ng di ba? And that's the output, guys. Kung isasama natin details is equal to true. Yan, you see how many lines those are. Kasi yung details is equal to true, inisa-isa niya, no? Step by step. Yung sa walang details is equal to true, ito lang yun. Pinakita lang niya yung final answer. Step 1, pasok sa education. Step 2, sa tenure. Step 3, pasok si gender. Step 4, si civil status. And then ito yung mga measures niya. As we add more, okay, hanggang 4 lang. Okay, so dito kay forward stepwise regression, pareho dun ang answer niya, dun sa answer natin kanina, di ba? Remember yung answer natin kanina, tayo? Yung inisa-isa natin, yung LM natin, yung mga models natin. Lumalabas na 4 yung natin, 4 na predictors yung final model natin. Ganon din dito kay forward. Okay, tapos yung question is Steph, repeat ko lang, ito, walang details is equal to true, di ba? Ito, wala, hindi natin linagay. Kaya, binigay lang niya kagad yung final output, yung pinaka-summary lang. Wala nga ditong di ba? Tingnan nga natin, let me see. Ano ba tong forward fit na to? Okay, so it's also a list, no? Forward fit. I click this. Ayan, so may mga laman din siyang iba, yung predictors, no? R-squared, etc. Okay, however, guys, when we entered yung details is equal to true, okay, I'm not going to explain each one of this, no? I-explain ko lang yung first few steps, then I'm sure you'll be able to follow the rest. So yung first step 1 daw, add education. Okay, when you add education, ito yung magiging model summary natin. Okay? And then, nag-ANOVA siya, no? Ito yung ANOVA, ito yung analysis of variance. Okay, ito yung F-test. Ito yung So ito yung ANOVA dito, guys, yung overall goodness of fit test. So here we're saying that beta null is equal to beta 1 is equal to 0. We reject that hypothesis. Okay, so and then pinakita niya kung isa lang yung step 1 natin si education ang ipapasok. Ito yung mga parameters. Ito yung intercept, ito yung slope ni education. Okay, andi dito din yung p-value, significant value, tapos may lower and upper pa siya. Okay, so ito guys yung regression output ng model number 1 natin. So kompletong pinakita niya. So sabi niya next, okay. Tingnan natin kung pwede pa tayong magdagdag. So step 2 niya, si tenure ang pinasok niya. So pag ipapasok si tenure, kasama na rin sa education kasi, di ba, nauna sa education. Ito na yung magiging values ng adjusted R-squared, So, di ba, tumaas. Kanina 0.16 lang, ito 0.29. Bumaba yung mga Ramsey, yung root mean square error, bumaba yung mga measurement ng errors. Okay? Tapos, yung ANOVA natin, ano yung p-value? Significant. Ibig sabihin na may isang predictor na significant. Overall goodness of fit natin, okay. Right? And then, ito na yung parameter estimates. Education, tenure. Ito na yung mga values niya. Ito na yung t-value. Okay? Ito yung kung significant siya o hindi. Okay? Alright. So, step by step yan. No? So, susunod naman, si number 3, si gender. Susunod si number 4, yung last, si civil status. Nung pinasok si civil status, guys, kinumpute na naman yung mga adjusted R-squared, etc. Tininan din yung ANOVA. No? Okay, so goodness of fit natin, okay. Alright, tininan yung mga values ng parameters. No? Okay, lahat siya significant. All are significant. Tapos, look at the last step. No more variables to be added. Ito daw yung mga variables added, yung 4 na yan. Okay? There, no? And then yung final summary niya, no? Yung model summary. Yan, final model output. That one. And then, isa na yung regression estimates natin. Education, tenure, gender, at saka civil status. All of them are statistically significant. 4 sila. And then, inano lang niya, sinamarize lang niya. Ito guys, yung nakita natin dun sa walang details is equal to true. Ito yung nakita natin. No? Yung step by step lang kung ano yung dinagdag na. Okay, pause muna ako guys. I'm sure medyo ang daming ano nito, no? Ang daming details na ano. Pero once you understand the first one and the second one, guys, wala na. Tuloy-tuloy na lang yan. Pare-pareho na lang yan. No? Iterated lang yan. Okay, so let me pause for a while, guys. I'd like to entertain questions. If you have any clarifications, please don't be afraid to ask. Alam niyo naman na napaka-safe environment natin. We appreciate questions. Okay, ini-encourage natin siya. No questions, guys? O feedback naman. Kung walang questions, okay. How do you explain yung okay, thank you for the question. Final model output natin, ito. Okay, diba? Mahirap adjust dito. All right. So, is this what you're referring to? This one? My parameter estimates? Okay, thank you. All right. Ito guys ito yung parang regression natin kanina, no? 'Di ba? Ito yung natin, intercept, ito yung mga parameters natin, education, tenure, gender, male, civil status. Ito yung value natin, ito yung estimate natin. Ito yung beta. Okay? So, itong 0.529, 'di ba? In-interpret natin 'to. For every 1 year increase in education, there's a corresponding $0.53 increase in hourly wage, ceteris paribus. Okay? So, yung standard error at saka yung beta, importante lang yan para i-compute yung t, no? So, hindi natin titingnan yan. So, itong t-value, ang tinitingnan natin yung significance, di ba? So, lahat dito guys, ang pinasok dun sa forward stepwise regression are all significant. Ito guys, pinakita lang dito yung confidence interval. Okay, so this just proves guys na significant talaga yung mga estimates natin. Bakit? Ito daw yung lower value, 95%, no? Tapos ito yung upper. Is it possible na tamaan yung 0 dito? Hindi. No? Pwede lang tamaan yung 0 kapag negative yung lower, tapos positive yung upper. Pero ito parehong negative, yung lower at saka upper. Ibig sabihin, when we go here, it will never reach 0. Ito din, 0.43 at saka 0.62, hindi din tatamaan yung 0 dito. Sa lahat ng to, kaya nga significant sa lahat. Pero kunyari guys, ito negative 1.225, tapos ito positive 0.146. This will be insignificant. No? Okay? Kasi magkaka-possibility na 0 can be a value of your beta, of your estimate, of your parameter. Okay, so itong parameter estimate, ito guys yung final ano natin, final output natin dun sa regression natin. Ito, yan. It's the same. Wala lang nito, no? Hindi kasi natin generate dun sa regression model yung lower at saka upper. But the rest are the same. Okay? Andito din guys yung ano, yung mga wala dito yung ano, no, yung adjusted R-squared, pero andi dito siya. Yung adjusted R-squared, clear ko lang to. Sumasama kasi yung ano yun. Kaya dito siya, binigay naman ito adjusted R-squared. In fact, mas maganda nga yung output, naka-table siya. So yung final model output natin, kasama yung mga F-stat natin, pati yung mga ibang error terms na hindi kasama dun sa LM natin. Tapos andi dito din yung table ng ANOVA. Okay. Yung ANOVA guys, analysis of variance. Remember, ito yung goodness of fit test overall. Ito yung tinetest kung beta null is equal to beta 1, is equal to etc. is equal to beta 4. No? Kasi 4 yung predictors natin. 4 to, then it's equal to 0. Okay? Beta 1 hanggang beta 4 is equal to 0. So we reject this, no? Because you have significant value. Okay, p-value is less than 0.0. Okay. Thank you for that question. Did that answer your question, you? You na-answer ba yung question mo or kulang pa yung explanation natin? Okay, good. Thank you. Okay, no other questions, guys? Sige, let's proceed, no? Let's proceed. Okay. Ito naman, guys, forward regression naman. Kanina using p-value, ito naman using AIC. Using AKIK. Okay, so same thing guys, ang kaibahan na lang, hindi na underscore P to, underscore AIC. So dito ang gagawin niya, ang gagamitin niya si AIC para malaman kung anong variable ang papasok. So once again, if we print this, either print natin to, yan. Okay, so final output na lang lahat, no? Tapos itong code na to pareho din ilalabas. So dito guys, ang inaano niya, ang pinapakita niya, yung 1, 2, 3, 4. Okay, tingnan nyo guys, no? Ito yung selection summary, ito yung final model. Dito guys, sa final model, 5 yung predictors. So may kaibahan tayo dun sa p-value kung ang ginamit, no? Take a look. May education, tenure, gender, civil status. Kasama yung experience. Kasama yung experience. So, iba yung result, guys, kung ginamit natin yung AIC, okay, as against p-value. So, magkaiba ng result, no? Okay, different result. Tingnan nyo, guys, bakit? Pinasok pa rin si experience kasi ang AIC niya mas mababa kaysa kung hanggang kay civil status lang. Okay? Kung sa education ang AIC ng model 277. Pag pinasok sa tenure, nag-i-improve yung AIC. Pag pinasok si gender, nag-i-improve ulit yung AIC. Pag pinasok yung naging 4 na to, nag-improve yung ulit yung AIC. Pag pinasok tong 5 to, nag-improve pa rin yung AIC. Eh sabi natin, kung gusto natin, kung based on AIC. No? So sometimes nagkakaganon guys, magkaiba yung final model ni AIC, magkaiba yung final model ni p-value. Okay, but oftentimes, guys, mas ginagamit si p-value. Unless i-relax natin, no? Unless i-relax natin yung required na significant level of significance natin. Okay? Instead of using 0.05, kunyari kung gagamitin natin a more relaxed one na 0.10, okay? 0.10. So chances are, guys, baka magpareho din si pareho din si p-value at saka si AIC. Alright. So ito yung final model, guys, no? That's the final model. Okay, clear ko muna to. That's the final model. So okay, pareho lang to, guys, no? Pareho lang tong. Okay, let's take a look at this. Hindi natin ginamit to kanina, no? Okay, let's use this plot function. Plot fwd.fit.aic. Ito yung object na create natin. So let's plot this and see the plot that we'll be getting. Okay, take a look at this, guys. I-maximize natin. So what we have here, guys, is a plot for a stepwise forward regression using AIC. So this is the measure of AIC if you only introduce education to siya, to something. Pag pinasok niyo si tenure, grabe yung bagsak ng AIC, no? Pag pinasok niyo si gender, bababa pa rin yung AIC. It keeps on going lower. Ito yung lowest. Pag nagdagdag ka pa ng isa, guys, tataas na yung AIC niya. That's why it stopped here. So based on AIC, guys, kasama si experience dun sa final model natin. Okay? Is that clear, guys? Clear ba? Okay, chat naman please kung clear. Okay, I hope everybody chats, guys, kung clear tayo so far. Okay, good. Okay. Reviewin nyo to, guys, yung model na to, ha. Okay. So again, ito, guys, yung maglalagay din tayong details is equal to true, no? Then parenthesis para automatically i-print niya. Now, pag print ko to, iba yung pangalan, forward fit 1, no? .aic naman. It will also generate yung step by step. Ganun na naman. Pareho lang. So ang haba, guys, ng ang haba ng output. Okay? So let's just take a look at the first few, kasi maintindihan naman natin kagad yan. So ito yung mga candidate terms. Remember, this is forward, no? So isa silang ipapasok. Tingnan nyo to, guys, no? Okay, hourly wage regress on 1. Ibig sabihin, guys, regress on 1, intercept lang yung yung predictor niya, yung average lang. So kapag walang variable na gagamitin, ang AIC natin 2870. Pero ang sabi niya, if you include education, AIC will become 2777. If you include race, AIC will become 2871. Okay, tingnan nyo, guys, pag ipasok natin si race, mas tataas pa kaysa yung AIC kaysa dun sa wala tayong predictor. Ito, yun ibig sabihin, no, guys, tilde 1, ibig sabihin, yung intercept lang yung natin, wala tayong predictors na gagamitin. So sa lahat, guys, ng instances na to, mas maganda na, di ba, lowest AIC siya. Si education, ipasok si education. Kaya nga, yung next step dito, ipapasok si education. Kaya nga yun, no, plus education. Okay? So ang step 1 natin, where hourly wage is now regressed on education, your AIC is now 2777. Mas mababa na. Okay, so next, guys, titingnan tayo dito. Kung ipasok natin si tenure, okay, AIC natin will become 2685. Tapos andito pa yung mga measures, guys, adjusted R-squared. You can compare also between models, no, kung bumababa si adjusted R-squared. So among this, guys, ang pinakamaganda si tenure ipasok natin. Kasi bababa si AIC ng pinakamalaki. Alright? So plus tenure, ang model natin ngayon, hourly wage regression education plus tenure, ang AIC natin na bago, 2685. Kanina 2777, bumaba siya. So mas okay. Kasi ang basis natin dito, AIC. Right? Okay, and so on and so forth, guys. Ganun lang yan. Same banana. Same everything. So since, if you know the first pattern, if you know the pattern for the first model and the second model, then you'll be able to interpret yung iba, no? Yung mga susunod dito. Tapos nagdadagdag siya. Okay, tingnan nyo guys, no? So dito, ito apat na dito eh. No? Apat na yung ano natin dito. Hindi. Tatlo pa lang dito, no? Tapos sabi, ang 2643 yung AIC natin. Pag nagdagdag tayo ng civil status, bababa. Kaya nga pinasok niya si civil status. So ito na yung apat na regressors natin. Okay? Tapos again, sabi niya, pag nagdagdag tayo ng experience, bababa pa yung AIC. So pinasok natin si AIC dito. Kasi ito nga yung sinasabi natin na basis ng model na to. Which is not like the other one kanina na ginawa natin na p-value yung basis natin. Okay, so ang lesson natin dito guys, pwedeng mag-conflict si AIC at saka si p-value. No problem yun. Okay? Kasi magkaiba naman sila ng computation. But it will not be very far. And if ever guys, we can decide to follow the p-value kasi yun naman yung sinusunod kadalasan. Alright? So, anong nangyari dito? So, dinagdag niya si experience. Okay? So, ang naging AIC na, 2638. So, ang model natin, HR Luigi, regression education, tenure, 5 na yung ano natin. Tapos ito, sabi, pag nagdagdag pa tayo number of dependents, wala na, hindi na pa pwede kasi tataas na yung AIC. 2638.8 to 2638.6. So, nag-stop na siya dyan. Kaya nga, no more variables to be added. So, ito lang, 5 lang. No? Okay, then again here, dito na yung model summary natin. Okay, dapat guys, ano kayo dito yung naiintindihan nyo ito, iba't ibang measure lang ng error to. Since sinabi natin na Ramsey kanina, root mean square error. Ito mean square error. Inad lang yung mga errors, tapos kinuha yung average. Mean absolute error guys, may formula din yan, no? Absolute, kinukuha yung difference ng fitted at saka ng actual value, tapos kinukuha mo yung absolute value niya. Okay? Tinatanggal natin yung negative, tapos i-add siya lahat. No? Okay, so different types of error measures, and we want, of course, that the error measures to be very low. Okay? So, adjusted R squared 0.362. Andito yung ANOVA ulit. ANOVA is here. Tapos ito na naman yung parameter estimates natin. But take note guys, take note of the experience. Pinasok sa model, pero hindi siya significant. Yun. Okay? It's not even significant at 0.10. It's not significant at 10%. Significant na lang siya at at 15%. So ito guys yung problema natin kapag AIC yung ginagamit natin tapos nagkakaroon ng conflict. Okay? Kasi dito guys, ang level of significance niya is ang p-value is 0.12, which is way higher than 0.05. In fact, kung ang single, barely, 0.051. Tapos tingnan nyo guys, no? Tingnan nyo to. Yung yung confidence interval, tatamaan yung 0 eh. Kasi negative dito, negative, tapos positive to. So, you notice guys na naapektuhan din si civil status single, Parang naging barely significant na siya kasi pinasok natin sa experience. Kasi yung last model natin kanina, hindi naman yung ang ginamit natin, significant, highly significant significant naman si civil status eh. So, na-notice natin na pinasok natin to, naapektuhan din si civil status. Okay? And finally, sinummarize na ulit yung selection process. Okay, pause ulit again, guys. Any questions so far? Okay. How about feedback, guys? Kung okay so far, ano ba na? Nag-feedback na pala kayo. Okay, good. Thank you. Alright, so yung OLSRR, kaya niyang gamitin, guys, yung forward regression, forward stepwise, at saka backward. Okay, itong backward, ito yung ginawa natin kanina, no? Anong kaibahan niya? Yung code, no? OLS step, kanina forward, ngayon naman backward. Okay, so pareho lang, guys, no? So we'll create this object, backward, fit.p, p na naman yung gagamitin natin, at saka remaining, no? Kanina enter, p enter. Kasi papasok lang siya kung it will produce less than 0.05 na ano, no? Ito naman, magre-remain lang siya kung less than 0.05 yung p-value. Okay? So same thing as kanina, yung summary lang at saka yung details. Okay, so let's run this. Okay. Asan na? Wait, parang tama ba yung natin? Tama yung model, di ba? Okay, bakit kaya tatlo lang to? P-value. Wala yung civil status. Strange yan, strange. Dapat pareho lang to ng kaninang model natin. Let me backtrack a bit, no? So yung sa model number, model number, ano yun, 4, yung final model natin, ayan, no? Education, tenure, gender, and civil status. P-value niya 0.01, so significant siya. Now, bakit yung OLSRR ang ginamit natin? Actually, guys, strange siya kasi ilang beses ko na itong ginamit. Then, hindi naman ako nagkakaproblema. Pareho lang yung lumalabas. Okay, anyway, so let's just proceed, no? Dito, ang sinasabi niya, kasi ang model natin yun din eh. Ang model natin, yung regression equation natin, yung lahat ng variables, di ba? Ito yung model natin, yung object na model. Asan yung una natin? Ito, model is equal to LMRU, which regress on lahat ng variables. Yan ang model natin. Tapos pina-stepwise natin yan kay R. So this one, let's see this. Tatlo lang, no? Bakit kaya? Okay? Sige, tuloy lang natin, guys, kasi something seems to be, baka, tama naman yung code natin. Our code is correct. Tama. Okay, let me create now a backward fit one na isasama natin details. So let's include the details. Mahaba din to, no? So kung anong ginawa kanina, guys, sa AIC, ganun din, no? Pero dito, anong nangyayari, okay, una muna, pinasok niya lahat. Kasi backward to, di ba? So lahat pinasok niya, tapos titingnan niya, anong tatanggalin? Okay? So ito sasabihin niya, kung tanggalin to, ito mangyayari. Etc. etc. So step by step din yan, guys. No? So, ito tinanggal yung race. Ito nangyari. Tapos next daw, tatanggalin si number of dependents. Okay, so let's take a look at the final model. So dito, tatanggalin naman si experience. Okay, so tinanggal sa experience, education, tenure. Ito na yung final model natin kanina. Yung apat na variables yan. Tapos sinabi niya dito, sinummarize siya. Ito na yung variables na tinanggal. So tama pala. Kasi final model na. Bakit sa printout kanina parang mali? Okay, so you see, guys, apat yung yung predictors natin tama. Pero kanina bakit yung ito? Bakit tatlo lang to? Diba, guys, yun nyo? Exit the space. Tatlo eh. So, nag-conflict siya. I'm surprised about this. No? Nung hindi natin sinama yung details, sabi niya hanggang experience lang. So, may mali ito. No? Pero nung sinama natin details, yung final model na guys, yung 4 na variables ang significant. Take a look. Ah? Ay, sorry. Okay guys, my bad. I'm wrong guys. Mali yung ano ko mali interpretation ko. Tama pala to, no? Okay, ito. Guys, take note. Ano to yung backward, no? Ito. Mali ako. Elimination, guys. Ito yung tinanggal yung 3. Okay? 3 yung tinanggal. Okay, so race, number of dependents, experience. Tinanggal yan. So tama itong output. Sorry, I was I was focused on the forward stepwise regression. So backward to, so ang pinakita sa akin yung mga tinanggal. Alright, so ganun din guys, ito yung mga summary estimates natin. Ito yung final model output natin. Ito yung ANOVA natin. Okay? Ito yung mga parameter estimates natin. Ito yung estimates. Ito yung mga values sila. Ito yung mga significant, yung p-values. Again, tinan nyo guys, walang tumatama dun sa ano, no? Hindi tatama yung 0 dito, in between this lower and upper. Okay, so pinakita ulit yung elimination. Hindi ito yung variables na final, ito pala yung mga eliminate. Okay? Alright, then there's also this one, pwede ka rin mag-backward kasi ito using p-value. Ito naman backward using AIC. So i-print ko lang guys yung final model. Tingnan natin kung sa backward, kasi sa forward magkaiba yung ano, di ba? Kanina sa forward, iba yung results ng AIC, iba yung results sa p-value. Tingnan natin guys kung sa backward regression, pareho lang si AIC at saka si p-value. Let me print this. Okay. So, ano nangyari dito? Full model. Okay, ito yung AIC. Pag binawas si race, ito yung AIC. Pag binawas si number of dependent, ito yung AIC. So, dalawa yung tinanggal nila. So, pareho guys, si backward na AIC at saka forward na AIC. They should be the same. Okay? So, ito guys, ang in-eliminate lang dito dalawa. Pareho lang yan dun sa forward natin na ang pinasok nila 5. Okay? So, I will not anymore print this guys. Kayo na mag-ano nito, no? Anyway, pareho lang naman yan. Okay, I'm sure you can easily understand yung kung ano yung nakalagay dyan, no? Alright, let's just take a look at the backward, okay, backward AIC. So, dito kung tinan nyo, no? Ito baliktad. Kanina sa forward, kung anong variable ang idadagdag. Ito naman, kung anong variable ang ibabawas. Kasi backward nga tayo. Full model, tanggalan ni race, bababa yung AIC. Tanggalin yung number of dependents, bababa yung AIC. Pag nagtanggal ka pa ng isa, which was dun sa ano, civil status yun tataas na yung AIC. So dito ang naging basis niya yung AIC. While yung sa isa ang naging basis natin yung p-value. Okay, so you see the difference. Okay, any questions so far guys? Pause muna ako. Any questions? Kung clear, paki-chat na lang, please. Okay, very good. Very good. So guys, importante itong ano na to. Now sa project nyo guys, now, hindi natin kailangan yung ano, yung ipapakita nyo pa yung, magbibigay ako ng examples ng output na gusto kong dapat ganun yung outputs nyo. Kasi minsan guys, sa mga outputs, ang pangit ng mga outputs na generate kasi yung mga hindi naman kailangan dapat ipasok sa ano, ipasok sa output, pinapasok pa rin. There are some things here that should be sa appendix, dapat sa appendix yung ilagay yun. So you can do that using R markdown. Okay. So, alright. Tinat natin yung intermediate steps. I'll leave you to that. Okay. Now, ito naman, saan na to? Stepwise regression using p-values. Yeah, I think we did this already. Alright. Saan ba ako? Ba't parang naulit yata? Wait, no? So, dito tayo tapos kanina. Diba, we're done here. Okay, and then, ito yung details. Stable ng internet ko. Tapos, ito yung plot. Alright. Details is equal to true. Okay. I think naulit guys yung ano. Ay, sorry. Mana pala tayo. Okay. Kanina backward guys. Now ito, merong isa pa, no? Yung both. Okay, combination ng ano ng backward at saka forward. Others call this the mix, no? So, forward combination ng forward at saka backward. Tingnan natin guys kung ano, kung may kaibahan, kung combination ng forward at saka backward yung magiging answer. Let's just take kaya nga dito dalawa, no? P entering 0.05, P remaining 0.05. Okay, let's just see kung i-combine natin. All right. So that's why yung output nito guys, inalagay kung added siya o removed. So nagsimula siya guys na mag-add. So nagsimula siya sa ano sa forward, no? Actually hanggang natapos forward siya. No? So walang difference, wala siya nakita kung i-combine niya. The best method pa rin, well for this, no, for the both is nag-add lang siya ng nag-add. Okay, so we have here the result na pareho lang dun sa ano natin, sa p-value result. Education tenure, okay. Okay, so ito yung ang tawag dito guys, stepwise lang. Stepwise regression. Hindi siya backward stepwise, hindi siya forward stepwise, stepwise lang. Combination siya ng forward at saka backward. And then, ganun din guys, yung details, isa-isa niya ipapakita kung paano nangyari ito. So I won't run this anymore. Okay, so this is yung both ano, using P. Tapos ito naman, both using AIC. So both stepwise and backward and forward, pero ito ang gagamitin niyang AIC. So let's take a look at this. So pareho lang, no? 1, 2. Pero guys, ang nangyari dito, since ang ginagamit ng AIC, sinama niya si experience. Kasi pagkasama si experience, mas mababa yung ano, yung AIC, 2638 siya. Okay, so I hope clear guys na na consistent, no? Kung AIC method ang gagamitin, for as long as bumababa yung AIC, ipapasok pa rin yung variable na yan. Okay? Even if yung adjusted R squared dito, mas gumanda definitely guys, pag nagdadagdag tayo ng variable, mas tataas yung yung R squared natin. Okay? And sometimes also the adjusted R squared, but not always sa adjusted R squared. All right, then we also plotted this. Plot, ito both fit, no? That AIC. Yung AIC lang pwede i-plot natin, hindi yung p-value. All right, so stepwise, AIC, both direction selection. So dito ang lumalabas na nag-backward siya dito, no? Although stepwise ang tinitingnan niya guys kung mas maganda ba mag-add or subtract. So ina-account na yun. So dito ang lumalabas sa kanya, mas maganda kung magsimula sa sa education muna, okay? Tapos magdagdag ng tenure, gender, civil status kasama si experience. Okay, which is the same as yung kanina sa forward natin kanina. Okay? So okay, just a few more guys. Ito, no? This one. Okay, this is all possible subsets regression. Ito tingnan natin kasi medyo malaki tong output na to, no? So let's run this. And it will give us all the possible models. Yan. So, ang daming mga outputs, no? Let's print it. Ito natin tingnan. Okay, so what's this giving us, guys? Hindi maganda yung print. Dati mas maganda yung print. Okay, what is this giving us? Let me try to run this dun sa i-run ko siya dito sa, tingnan natin kung mas maganda yung pag-print dito. Ito, no? Mode compare, all else. So let me print it here. Natin kung mas maganda yung print out dito. Oops. Sige, I'll run this. Control Enter dito sa console. So viewer ba lalabas? Okay, hindi lumalabas sa viewer. Wala rin sa plot yun. Okay. Ayaw niya lumabas sa viewer. Let me repeat. Ayaw lumabas sa viewer. Okay, anyway guys, let me just explain what okay. So, 127 rows, guys. Ano ibig sabihin yan? 127 outputs. So, this is a complete output of all your models, no? The previous. So, model 1 natin, guys. Ilan ang predictor natin? And isa lang, sa education. Andiyan yung adjusted R squared, tsaka Mallows CP. We'll explain this later on. Now, linagay niya lahat, guys, ang lahat ng kung ang tenure ang predictor, kung si gender lang, kung si civil status lang, kung si experience lang. So lahat nila, linagay niya, yung possible combinations ng ng mga predictors. Kaya nga naging 127 possible models. Okay, di ba? No? So, in terms of adjusted R squared, kung isa lang yung predictor natin, tignan mo si race ang pinakamababa. Si education yung pinakamaganda. Okay? Alright. Now, kung dalawa guys, kung dalawang predictor, i-release niya itong dalawa. No? Education at saka tenure, ano kaya? Education kaya at saka si gender. So, pinir niya, no? Natin 2. So, lahat ng education. Tapos si tenure naman, okay, pinag-prepare niya lahat kung dalawa yung kung dalawa yung predictors. And then, okay, so tingnan natin, no? Yan, kung 4 naman yung predictors yan. So lahat ng possible combinations sa 4 na combination yan, hanggang 7, no? Yung 7, iisa lang yan, di ba? Ito lang yon. Kasi, iisa lang naman ang possible na lahat sila. So you see here, guys, a very powerful output na lahat ng output, no, generate niya. Lahat ng combinations ng output. Okay? This can be, okay. So pwede pala, no, compare na, gawin natin data frame. Okay, hindi ko nakita to, no, para ma-compare natin siya. As that data frame. So, asan na siya? Si mode compare ito. Ayan, yun siya, no? Ayan. So, naging data frame na siya. Yan lahat, no? So, andyan yung AIC, andyan yung Schwartz Bayesian, Schwartz Bayesian information criterion. May mga iba pang measures, no? I'm not familiar with this, but we can check this, what these are. So you can see, guys, the different combinations. Yan. Imagine, guys, no? Lahat ng possible combinations ng variables natin. Andyan lahat. Okay. Okay, clear so far, guys? Clear? Okay, chat naman, please, kung clear. Okay, the rest, guys? Clear ba? Okay, good. Good. Na-overwhelmed ba kayo, guys, sa ano? Pero I hope by now you're appreciating R, no? Grabe yung power niya, grabe yung ano niya, yung computing capability. Okay, tapos ito, we can plot. Si mod compare natin, di ba yung object? Ito yun. Yung data frame na to. We can ask R to plot this. Let's see kung ano yung kakalabasan nito. Okay, ito siya. Okay, so what is this telling us? Buksan mo natin yung... So, highlight natin. Alright. So, ito sabi niya dito. Ayaw mo ano. Mas lumiit. Okay, anyway. Oh yeah. Kung dito, hindi niya print. Okay, dito na lang. Okay, sa R squared, guys, ano ibig sabihin nito? Okay, this is 1, 2, 3, 4, 5, 6, 7, 7 to. Ito yung number of variables. So, ang sabi niya, kung isa lang variable, nakita niyo ito, triangle 1 is the best. Ano yung 1 na yan? Andito yan sa mod compare natin. Ito, si 1, si index na 1, yan ang best natin. Kung isa lang ang variable. Okay? Tapos, kung dalawa daw yung variables, if we're going to use adjusted R-squared as a basis, ano to? Hindi ko makita. I think this is... Ano number ba yan? Can you see, guys? Ano number to? Basta itong number, guys, ng pinaka-best model, kung dalawang variables, kung 3 variables ang gagamitin, kung 4, kung 5, kung 6, kung 7, andyan nakalagay kung anong best model in terms of R-squared, in terms of adjusted R-squared, AIC, MALOS, meron pang SBIC, related to kay AIC, guys. Schwartz Bayesian information criterion, Schwartz Bayesian criterion. So, pareho lang yan, no? Halos pareho lang yan. Konting nuances lang difference. Okay, so ito yung binibigay ng sa atin, no? Ng plot, no? Okay, and then lastly, guys, ito, meron din ito, OLS step best subset. No? Kanina, hindi subset to, no? Pinaplot lang natin yung mod compare. Remember, guys, ano yung mod compare natin? Yung mod compare natin, this is the model. This is the list, no? Yan. Mod compare, OLS step all possible ng model. Ito yung function niya. OLS, step, all possible. So, linis na lahat ng mga possible model ng regression. Okay, then, kinonvert natin into a data frame kasi mahirap hanapin dito. Yeah, I missed this kanina, no? And then, plot natin para makita natin kung based on SBIC, SBC, sino yung pinakamaganda. And lastly, guys, the all possible models gives us all the possible regression models. Pero if you have many regressors, you will take 2 to the k minus 1. Okay, you will take 2 to the k minus 1 you will have many regressors, which is, ano yung K natin? 7, no? 2 to the K, that's 2 times 2 times 2. 2 to the 5th is 32, times 2, 64, times 2, 128. 128 minus 1, so 127 possible combinations. Kaya nga 127 tayo. So that's the formula, no? That's a formula to get all the possible combinations in your model given your K or your predictors. So the more predictors, syempre, the more possible combinations. Okay? All right. So dito guys, ang gagamitin natin, OLS step best. Okay? And then, sino tayo nila? Ito naman guys, yung best subset na to. Okay? Let's make this mod compare 1 para maiba yung mod compare 1. Okay. So ito guys, no? Ito. So sinamarize na yan yung best subsets. Okay, so we can, I think, tingnan natin guys kung as that data frame. Let me see kung pwedeng, kung pwedeng gawin siyang data frame. Hindi. Sorry, hindi siya pwedeng gawing data frame guys kasi walang laman yung iba. Ang data frame dapat complete. But anyway, mod compare 1. Gawin lang natin alt minus. Okay. So let's see. Mod compare 1. Pwede pala, no? Okay. Kasi ano pala siya, name lang, akala ko mga ginawa siyang name. Okay, so okay, take a look at this guys. Ito na yung best solutions guys. Kung isa lang yung variable, and take a look at this, saan galing to? Yung index to ng mod compare, no? Number 1, number 9, number 35, number 77, number 102. Galing dito yan sa mod compare. Yan. Okay? So ito yung, kung isang variable lang, education yung pipiliin lang. Kung dalawa, education din. Kung lahat, syempre lahat, no? Okay. Kung titingnan natin guys, in terms of, AIC, no? In terms of AIC, ang pinakamagandang model, yung alam natin na 5 yung 5 yung variables, no? Ito. Ito. In terms of adjusted R squared, kasi pag nagdadagdag tayo guys, ang nagdadagdag, syempre, tumataas yung natin. Tumataas yung adjusted R squared. Okay, so makikita natin guys na it can generate for us a complete summary, no? And then lastly, plot compare 1 natin, mod compare 1 na to, no? Sorry, Control Enter. There, so, oops. Okay, parang, wait na. Parang correlation to. Guys, let me check, no? Okay, tama po. Medyo mahirap yung interpret guys, kasi. Okay. So, nakakahiro i-interpret. This is compare 1. Yung compare 1, ito na yung best subsets, no? Okay, I'm sorry guys, medyo I think I'm quite confused with kasi ito yung mga predictors natin. Ito yung index natin, okay? Ito yung okay. Now, hindi siya useful kasi nung plinat niya, guys, sinama niya pati ibang variables, so pati yung predictors. So, R squared. Okay, and it's quite difficult to interpret this. All right, so parang useless yata itong mukhang walang ano guys, mukhang walang no use itong plot mode compare 1 na to. Baka mali yung ano ko, mali yung function. But let me check this first. Okay, kung ano yung mali dito kasi iba yung binibigay sa atin. All right. Okay, so let's stop here for a while, guys. Kindly review this, and then next meeting, pupunta na tayo sa diagnostics. I don't want to start with diagnostics kasi halos 5 minutes na lang yung simula natin. And we need full time to really discuss diagnostics. Okay, any questions so far? Any questions, guys?
Sir.
Okay, thank you. Did you learn something tonight, guys?
Hello, sir.
Yes. May question pala. Yes.
May question lang para sa yung sa table.
Sige. Para saan? Sa?
Yung sa table. Kasi two decimal places lang sa akin.
This
Paano-
one?
Hindi. Yung sa mode compare 1.
Compare one? This one?
Oh,
Ito to?
oh.
Ang
Yung-
lumabas
Yung
saan?
decimal places, dalawa lang sa akin.
Dalawa lang. Okay, so sa compare one, ano, dito. Even dito sa sa script window, 2 decimal places lang lumalabas sa kanya.
Yes, sir.
Dito dalawa lang din.
Yes, sir. Dalawa din.
Let me figure that out, no? Kasi baka nag-default siya. Now, si Yuton, are you? Is it you?
Si Willie.
Willie, sorry. Willie, sige, let me check that first. It will be quite difficult to answer that now kasi nag-default si nag-default si R. Pero itong function natin, default lang din naman to. Wala naman tayong ibang ginawa eh. Nasa ano kaya yan? Lahat ba ng answers mo, Willie, nag-2 decimal places?
Kanina lang. Na-fix
Ito
ko
lang,
na ngayon.
ito lang.
Okay na, sir.
Okay na, bakit? Anong ginawa mo?
Nirun ko lang ulit. Tapos,
Okay.
na okay na.
Kanina siguro nag-truncate siya, no? Okay, thank you, Willie. Ikaw din pala nakasagot sa question mo. Okay, so let me stop recording this now. All right, so guys, stop recording.